So today we are going to solve a super popular Leetcode problem that is called push dominoes. Okay, let me read the question. There are n dominoes in a line and we place each domino vertically upright. In the beginning, we simultaneously push some of the dominoes either to the left or to the right. So after each second, each domino that is falling to the left pushes the adjacent domino on the left. Similarly, the dominoes falling to the right pushes their adjacent dominoes standing on the right. When a vertical domino has dominoes falling on it from the both side, it stays still due to the balance of the forces. For the purpose of this question, we will consider that a falling domino expands no additional force to a falling or already fallen domino. Okay, and you are given a string domino representing the initial state where domino at I is equal to L if the ith domino has been pushed to the left, and dominoes at I equal to R if the ith domino has been pushed to the right, and domino at I is dot if the ith domino has not been pushed. Return the string representing the final state. Okay, once again pause this video, go through the statement again so you will have the clear understanding of the problem overview. Okay, so let me explain what we are trying to achieve here and what the statement is saying. So you have a row of domino, right, and sum of R pushes to the left, that is called L. So sum to the right R, that is we used to talk right R, and sum still stands means dot. Means if it is getting pushed, we'll call L. If it is pushed right, we'll say R, and if there is dot means it has not been pushed. So three things is there that you have to understand, right? Means you have a row of dominoes, some are pushed to the left, some is pushed to right, and some are not getting pushed. Okay, so after each second the force spreads to the neighboring upright domino, and we need to return the final state after all the dominoes fall or stabilizes. Gotcha? So let's understand like R domino pushes to the right, L domino pushes to the left, and if both meets at a domino at the same time, it stay at as a dot. We can say that, right? Or we can say that if there is R, if there is L, means something happens. Someone is some domino is pushes to the left or right? But if both forces left and right meted at the domino at the same time, it stay at dot, right? Means there is some activities happening, right? But if nothing happen, then is dot. If both side happen, means still it is dot, right? Means something is happening there, right? Means both force meet at a domino at the same time. That is why it stay as a dot, right? Because it's not moving left or right. It is not getting pushed in right or left, right? So what's the plan, right? What's the plan? So we have to return a string and representing the final state, right? So the question saying this statement, we have to return the string representing the final state. But what's the plan? So the plan is we simulate rightward forces to the left to the right, left to the right. We simulate left forward to the left pass. So there will be two pass, left to right pass and right to left pass, right? So we have to simulate that one, right? Then we will compare both forces and will build the result. Okay, so why we use time based forces, right? Because instead of tackling physical forces, we simulate time, since the push so closer, dominoes feels stronger forces, right? So let's jump into the example first. Okay, sorry, I'll go with okay. So let's go with the example first. So let's try run the example that we have given, right? So if we'll talk about this example, right, this example is very important example, so you can understand, visualize this one, right? So first, pass the given right forces, how far from the R you are, right? So we can see we have dot, we have, then we have L, we have, then again we have dot, then again we have R, right? And then so many dots are there, then L R is there, then dot dot L R, L and dot dot, right? So for the first pass gives right forces, right? Right? So you can see, right, it is getting from the right side, it is getting the forces, right? Then then we have to understand how far from the right you are, right? And then second pass gives left forces, right? So second pass giving left forces, okay? And then we should understand how far from here to here we are, right? Means from how far we are from left. So we have to check, once you got the forces, you have to see how far from left and right you are, right? If you are getting the left forces, how far you came from the left. If you are coming from the right forces, how far you came from the right forces, right? And say, and then we'll compare both to decide the final state, right? So if we see the inputs, right, we are seeing that there is one dot, one L, right? And then dot R, and then these are dots are, right? Then but here the output is coming LL, means we are very near to the left side, LL, right? Then it is coming 2R, right? So we are we have getting pushed to this side. Now we are getting one dot, so LL dot RR. So as you can see, this helps you to understand, this output helps you to understand how far you are from left and how far you are from the right, right? And so the, so if we'll talk about the complexity, right? So complexity, we are moving from all the array, or the given number of dominoes, so it will become O of n, right? We are not moving so many times, right? We in an array, okay, we will move for O of n times. And we'll see how we are going to use to understand the space, right? So if anything will happen, we'll go for the because this is a string, right? You can use like all the characters we have to check, and then the complexity should be maximum O of n, right? And we'll see about the program, right? So now you understand, right, what is the problem here, right? So let's understand the intuition of this problem, okay? So how we simulate forces with the two passes, right? So if left to right we are going, right, means you are coming from this side, right? You are coming from this side, from left to right. If it is coming from right to left, we will come from this side, right? And then the final state will come like this, like this. So first you came left to right, let's suppose from this to this side, and then you have, for this right, you have made a force from left to right, right? Then for this state you came right to left, so you have given LL, and then you have made the forces, then there is dot coming from L coming. So if you simulate this, right, so L was already there, so there is no data was there, but there is L is there, but this we got what left forces we got right here. So we are getting dot here. Okay, because this was already left, right, and you made a right to left, and so because he has a left and you got the right forces, so it is coming dot. Similarly, one this is left is there and right is there, so it is going for the final state. Okay, so we simulate how force propagates through the domino. Means R pushes rightward until L ends its hit, and L pushes leftward until R and S starts is hit. When both right and left affect a domino at the same time, the closer one dominates, right? If equally distant, then it stay upward due to the equal forces. So we can simulate this by doing two passes, left to right, and we have to assign time since last R, and right to left we will assign time since last L. Okay, and then uh, will simulate the final state. Okay, so what we should do, right, to let me go here. Okay, now what I'm trying to explain after this code, right? So first of all, what needs to do, right? So first of all, create two integer array, left forces and right forces. Okay, so we have given domino, right? So we'll create n, and we'll create left forces and right forces. Okay, so what if you have two forces array in the array, right? Now we have to traverse left to right and right to left, right? So when we are going for the left to right for R pushes, let's suppose there is R pushes and we are going left to right, right? That I have already shown you the simulation, right? This is the simulation. We are going from left to right. So three passes will do left to right, right to left, and then we'll calculate the our code. Okay, so first of all we have given a domino, so we'll get the length from here and we'll initialize two length of this array, left forces and right forces. We'll calculate left to right first for R pushes. So we'll go for the for loop 0 to n, and we'll check if domino at caret I is equal to R, right? If domino at caret I is equal to R, then we'll what we will do, then we'll say force is equal to n. Okay, and else if domino at caret I is equal to L, right, then we'll apply forces to 0. Why? Because see, if the domino char at I at any of the index is R, right, means we are making the force left to right, right, and the character is already representing there is R, right, means it is already the right forces we have here. Okay, so we got the right forces left to right, so we got the right force here, and so the force is now n. Okay, so if it is L, right, if it is L, means will uh, apply is to 0, because we are getting left to right forces, right? And other cases will say force equal to force minus 1 comma 0, and will apply uh, to the force, right, whichever is the max. Force minus 1 and comma 0, whichever is the max, will apply to the force. And then why? Because see, force, at least there should be some data. Okay, not the negative force should not be the negative. Okay, at least some data will be there, forces, and then there will be either it will be 0, whichever is max, that will apply to the force. And the forces at I is equal to force at I, right force at I is equal to force we will apply, right? So first we are traversing left to right. We'll keep a timer for how far from the last R will apply, how far from the last will apply, and will reset if left is found. Okay, and for that, when we are going for the key, when we are going from right to left, then we'll apply, like we'll keep our timer of how far from LVR, and will reset R if it is found, right? Like similarly we are doing here. And for each index, we'll compare left forces at I and right forces at I. If it is equal, we'll apply dot. If it is less than, the left force is less than right force, we'll apply L. If it is right force is less than left force, we'll apply R. Okay, so this is for the left to right, and we are applying the forces. Okay, we will explain again. Just to give me uh, one pass to understand this, so we'll understand. Now we'll go for the right to left, right, to understand the L passes. Sorry, right to left passes. Okay, so for the right to left, there will be, let's suppose there is L pushes. Okay, so what we will do, we'll make the same loop like this, but in the reverse we will check now. And if we'll check, if domino at char at I equal to L. Okay, domino at dot char at I is equal to L, will apply forces equal to N, right? Because we are keeping a timer of how far from last hour, right? And so if in the else condition we are getting the right, we will apply forces as a 0. Okay, and then we will reset this, and we'll check the force, whatever is coming max, force minus 1 comma 0. Then we'll apply the force, and then apply left force at I. Okay, now we will build the result. To build the result, what we will check, we will compare for each index, we'll compare left and right force, right? So first of all, we'll create the string builder. We'll go for the all the loop, all the elements at all the dominoes, you can say, and we'll check left force at I equal to right force at I, means both forces are equal. We'll apply dot here, right? If left force is greater than the right force, we'll apply L, because we are getting the left forces. Left force is more. If we will check left force is less than right force, then we'll apply right in the else condition. Okay, so these three condition we have been told to implement that, and so we'll finally we'll return sp.to string, and we'll get the result. Okay, so I hope you understand the code, right? So we will summarize this once again, right? But you understand the problem, right? What we are trying to do here. Okay, so let me go again, and we'll come back to here. Okay, so let's go step by step to understand the code again. Okay, so the problem statement, we have been told that you have a string dominoes of characters, right? If there is R, then we are getting pushed to the right. If L, we are getting pushed to the left. If there is dot, upright, no pushed, right? So dominoes fall and influence their neighbor. We need to return the final state of each domino, right? So our key observation was like domino, first of all, domino fall sequentially over time, right? And for R keeps, right, R keeps pushing. Okay, so if R keeps pushing to the right until blocked by L or S, right, means that is why we have taken the loop of this for loop, and we have checked, right? So if domino char at I equal to R, what does it mean? Like R keeps pushing dot to the right until blocked by L or S. If we are not getting L or S, we will reach where? To the right, and so the force came is as a N. You got my point? What I'm saying, that domino falls sequentially over time, first of all, then R keeps pushing dot to the right until blocked by L, until blocked by L or S. In that case, what we should have, it should move to N, right? Because we are getting R, we are not getting L or any S. So for L or for any S, what will happen? It will be block, right? And so the forces coming is a 0 when we are going from left to right. Okay, similarly happen for when we are moving for the right to left, means I'm talking about this code. So when L right to left is happening, L pushes happen, right? For L pushes, right? And so if there is L is already there, right? There is no R and any S, right? So for L pushes dot to the left until blocked by R or S. In that case, we are getting force equal to N, right? Otherwise, we'll apply the force is 0, and similarly we'll calculate if nothing is there, we'll calculate the force here, whatever the max is there, right? So if the dominoes get equal pressure from both sides, right? If we stay upward, right, you can say, means dot, you can say dot, okay? And so we simulate the force propaganda, right? Like force, we are seeing how it is propagating, right? Propagation, right? From both right and left, right? So we understand how we simulate the force propagation from both right and left. So we have seen the both, and this is for we have seen the right passes and L pushes. Okay, we have completed this. And so if we'll talk about the third one, right, this was the given thing to build the final result, right? So first of all, what we have done here, we have created, we have set up the arrays and initial forces, right? So we should create the left force, right force arrays, right? And we will initialize the force as a 0, right? So the first task is to do is set up the array and initialize the force. Your first to do step will be this one, right? Then we have given how many domino, the length of the string is N, right? So we will do dominoes dot length and you will get the N, right? Now we use two arrays, left and right forces, right? How? So the left force, the left at I, let's suppose left at I, okay, will contain the strength of force from right side at the index I, okay, and the right at I, right force at I will store the strength of the force from left side at the index I. Means the index I will contains both side of the forces, right? You understand, right? So the index, for the index I will contain the both side of the forces, right? And so if you observe, if you come here, we will update the left side and right side forces, right? We are updating right side forces, then we are updating the left side forces. So once you will calculate the right side and left side forces, your job is to just check the equality. If it is equal, apply dot. If it is greater than, apply L or R, right? Right? So we use force to simulate how strong the push is and how recently it happened, right? Right? I hope you are understanding, guys, right? So the first step is to calculate the right side, right force at I and left side at I. And for that, we have to set up the string first, and then you have to go for the R pushes and L pushes to calculate the right force and the left forces. Once both have calculated, you can easily calculate in the dot in the result building what is the force at a particular index. So when we hit R, we start applying max forces to the right of n. When we hit L, it blocked by any rightward push, and when we are getting for dot, the force weakened by once every step until 0. So that we also to take care of that, and so in these passes you have to take care of that, and you have to store the result in the right force at index. Okay, so why we are talking about this one again, because see, to simulate the force from R means left to right passes, means we are talking about the R passes, right? When we hit R, let's suppose when we are hit the R, right? We start applying max forces to the right. So max, what is the max forces? Force equal to N, right? And then we will check further, are we hitting L or any edges coming, right? So when we hit L, it blocks any rightward pushes, and so it is becoming 0, right? When we are hitting dot, right, force dot, right, when for the dot force weaken by one step, one every step until 0. Okay, and so we can take what is maximum between the force minus 1 and 0, and then finally we'll store right force at I, will store the result. Okay, similarly we have to simulate the for the left pushes, right? And so to simulate the force from left, right, means right to left pass, what we have to do, we have to do the same logic but in the reverse condition. If we find the L, means we will apply all the forces, right, and in the uh, in the left force at I, we will apply the force. Okay, finally we have the build, and in this build, at each index, if both side have the equal force, will apply dot, it means it's balance and stay upright. If it is left forces is a uh, stronger, then will fall left side, and so we'll apply L. And if right force is stronger, will fall right, and that will apply. And so the final result, we have to return the constructed a string that represented the final state. And that's all I have today. The time complexity will talk about, where n is the length of the domino string. So we are going for the first pass, we are going from the left to right, and we are getting for the R pushes, and similarly we are getting for the left pushes. Then we make a final linear pass to determine the result based on the forces. So total 3 times we are making the proportional operations on the given strings, right? And so still we will calculate as of n times, and we are taking the space, right? And for the space complexity is also of n, because we are using two arrays, left and right, right one, to track the forces at I. And so we are building the string builder as a new character array, but still that is auxiliary space, and so we'll take of n time, right? Thank you guys, thank you for watching this video.